Kia ora and welcome to this video going through question 3a of the 2014 Schol Calculus exam. Get a pen and paper, read through the question below and have a go at doing it on your own before I go through it step by step. So the first thing to do with scholarship questions is to read the question very carefully and identify what you're being asked to find. So in this case it's a question about a narrow rod that is 12 centimetres long. So there's my narrow rod. It's got a point A at one end and it's got a density given by the function rho of x, which is a fairly straightforward function. Notice that B and R are positive constants. We're asked to find the centre of gravity, which is C. So somewhere in here there will be a point that satisfies this integral. So basically we're going to substitute into the integral and then solve the resulting equation to find the value of C. So that might give some of you enough to get started. Try substituting in and then continue the video when you've done that. Okay. So we've got rho of x times x minus c dx equals 0. Substituting in we get this. Now as usual there are lots of ways to proceed. I'm going to take the constant term outside the integral and then I'm going to expand out this expression here. So I get b, and then the integral is x to the r times 12x minus x squared minus 12c plus cx dx equals 0. At this point you should be feeling a bit more relaxed because there's not really much to it from here except for a bunch of level 2 algebra. So we'll just pop in a new slide so that I can keep on going. Again, I suggest that you pause the video and do this question as far as you can from this point. Remember your goal is to find C, the centre of gravity. So we have B now expanding out the brackets, so x to the r times the expression we had above. Okay, I can collect up like terms and I can divide both sides through by b at this point. So b goes. So we get 12 plus c x to the r plus 1 minus x to the r plus 2 minus 12 c x r equals 0. Okay, so I'm ready to integrate. Very simple integration, it's just the power rule. So 12 plus c x to the r plus 2 divided by r plus 2 minus that term there minus 12c over r plus 1 x to the r plus 1. And there are my limits of integration. And we want all of that to equal 0. Now this is, it's nice that we've got the lower limit of integration being 0 because I can see that everything inside is going to equal 0. So I just need to evaluate it at the upper limit of 12. So now we get 12 plus c over r plus 2 times 12 to the power of r plus 2 minus 12 to the power of r plus 3 divided by r plus 3 minus, now I'm going to do 2 steps in one here. I've got a 12 here, I'm putting in 12 here, so I'm going to have 12 to the power of r plus 2 here. Right, so I'm just working that 12 back into there. So then I've got this equals 0. So new slide. Okay, so I'm just going to rewrite that so we can see what we're working with. We've got 12. A couple of ways to proceed here. If you're comfortable, probably best at this point to divide both sides through by 12r plus 2. So notice that we've got this common factor in all 3 bits. So we're going to eliminate that. So we'll divide both sides through by that. It just makes the working a bit easier. Doesn't matter if you leave it in there though, it's fine too. So we're going to have 12 plus c over r plus 2 minus 12 over r plus 3 minus c over r plus 1 equals 0. And now we're back to about probably year 10 maths, which is very nice. We want to collect up the terms with a c in them. So we have 12 over r plus 2 minus 12 over r plus 3 equals c over 1 plus c divided by r plus 1 minus 1 over r plus 2. So just going through where that's come from, I've taken this term over to here and this bit here also over to here. Right, it's worth checking that you've got your signs correct. Very, very easy to make a simple mistake that's going to make the solution a lot messier. So here we can see that we want to pop those fractions back together. So we're going to have 12 divided by r plus 2 times r plus 3 equals c r plus 1 r plus 2. So this works out to be r plus 2 minus r minus 1. Unfortunately, I need a new slide, which is a bit of a pain. Let's go to the next one. Okay, so rewriting from the last slide, we had 12 times r plus 3 minus 12 over r plus 2 over r plus 2, r plus 3 equals c times 1. Right, a few too many brackets in there, didn't need all of those, but never mind. Okay, so you can see this is going to simplify very, very nicely. I end up with 12 on this side, r plus 3 minus r plus 2, so that just works out to be 1. Cross multiplying from the other side, I get this, r plus 2, sorry about the 2 colours of pen. Okay, and they simplify. So I'm left with c, centre of gravity is 12 times r plus 1 over r plus 3. Centre of gravity is 12 r plus 1 over r plus 3 centimetres from A. So there you go.